Alright, hello everybody. So today I'm going to be talking about how to use the Altmetric API in order to fetch altmetric data for a given paper. So I've got a Python script written up in Jupyter Notebook here, and I'm just going to switch to presentation mode in order to walk you guys through it. So doing this requires two libraries, the first of which is requests. So considering we're working with the web API and fetching data from the web, the request library is the way to go. So we're going to be importing that into our workspace. And then the other library we're going to need is the JSON library. So that comes in a little handier for in working with the kind of data we'll actually be getting from the API. So we're going to load that as well. Right, so now that both of those are loaded in, what we have in front of us here is the actual URL for the API, and I'm saving it to a string called API for ease of use. So I'll just type out the whole thing over and over again. One important thing to note before we go any further is that what I've highlighted here, that is the actual core API URL, so to speak. I've actually tacked on DOI here because I'm going to be searching for my paper's altmetrics using its DOI. So for those who might not know, DOI stands for Digital Object Identifier, and every paper has a unique DOI associated with it. So I've tacked that on over here because that's what I'm going to be using to search, but the Altmetric API can be searched. Other search terms can include PubMed IDs, for instance, and a whole host of other things that are all actually listed in the API documentation. But so I'm using DOI, it's in my string, and I'm going to run that. And then similarly, I'm actually going to save my search term, so this into a string called DOI. So this DOI here is linked to a paper by Watson and Crick, and it's about the structure of DNA. And it's the paper I'm going to be fetching altmetrics for today. So once I've got that saved, I can pull up a get function from the request library and then run that on my API string and my DOI string combined. So obviously the order here is quite important because this is effectively a URL when put together. And once we get data from that, I'm saving that into a variable called response. So let's run that. And now that that's done, the first thing we're going to want to do every time before moving on to anything else is checking the status code. So the status code of our request will tell us whether we actually got anything from it. We're likely going to see one of two codes. So the 200 is the one we want. It means that everything went all right. It means our data was fetched from the API, and we can move on to the next step without looking back. The 404, however, is something that you'd probably want to see less. So that means that nothing was found, or that no altmetric data is available for this paper. So that could mean, for instance, that maybe there genuinely is no data, or more likely that something might have gone wrong in your code when you're actually fetching that data. So that's one to look out for. Others, these aren't the only two status codes you might see. So there's a whole host of others, but you're not going to see them as much enough for me to really go into them over here, and they're also described at length in the documentation. So anyways, the takeaway is that these are the two you should most likely concern yourself with. So let's check the status code of our request here. And we see that it's a 200, which is great. And that means we can move on to the next step. So the data we've actually fetched is currently a bytes object, and we don't want that. We can't really work with that. However, it's actually very conducive to being switched over to a dictionary and then being worked with as we would any dictionary in Python. So this is where the JSON library comes in quite handy. So using that, we can actually convert it to a dictionary, which I'm calling result. So let's run that. And then once that's done, let's check to see whether result is in fact a dictionary, effectively whether that worked out. And we see that it did, which is great. So now that we have our data as fetched from the API in a dictionary, we can treat it as such, and that includes looking at its keys. So here I've added the keys attribute to result, and that should give me a good sense of what kind of data I've fetched. I've also nested that in a sorted function, so that will sort them alphabetically and make them a little easier to read. So we run that, and here we can see a good sense of what kind of data we've got. So the amount of times it's been cited by Wikipedia, for instance, it's DOI, which is what I used to search, the journal it's in, the PubMed ID, and the subjects involved, and yeah, it's quite extensive, as we can see. So why don't we look at the actual data itself? So I'm just going to output the entire dictionary, we can see some of those same keys, or all of them for that matter, but with actual data filled in. So there's the DOI again. You can see that's been cited 3 times in the past year. That's the journal's name. It's in 164 Mendeley libraries, and so on. So yeah, this is quite a bit of data. We've fetched it from the API with just a few lines of code, but you can see it's not really particularly readable. It's quite messy, in fact, despite us sorting it and everything. So generally speaking, you wouldn't want something like this to be printed out in your console, especially if you've got a lot more altmetric data than this paper has, which will often be the case for, let's say, a newer or more popular paper. So instead of actually just printing it out in our Python console and having a look at it there, a better idea might be to save it as a text file. So we're going to do that using the JSON library once again. So the dumps function in the JSON library can convert dictionaries to strings. So I'm inputting my dictionary, which if you remember is called result, and I'm also adding these 2 parameters here. So sort keys equals true should once again sort them alphabetically, and I'm setting it and giving it an indent value of 4, also just to make it a little easier on the eyes. So once I've saved that as a string, I'm just going to open up a file called results.txt, and obviously I want to write to it, and I'm just going to write the string to that. So that should just create a text file in the current working directory, and just save the dictionary to it. So I've got my working directory open here. Here we can see results.txt, which was made just now. And peeking at it, we can see all our data sorted a little more neatly with all the indents and all. And yeah, that's about it for fetching data from the API. So one thing I would like to add before I finish this up is that calls to the API are rate limited. So Altmetric recommends making no more than 1 call per second as far as fetching API data goes. So if you write a loop with a runaway function that's making hundreds and hundreds of calls in just a few seconds, you're going to get rate limited by API by Altmetric, and you're going to have to stop making calls for a period of time. So it's best to avoid that. So a good way to do that, if you're going to be using loops here, might be to use the time library and using the time sleep function, for instance, in order to make sure that your calls are staggered. But aside from that, that's about it. So I hope this helped, and happy data fetching and crunching and visualizing and all. Thanks, and I'll see you next time.